Okay, Saxon 4 Math Group, this is lesson 45. We're going to learn about parentheses and something called the associative property of both addition and multiplication. We're also going to talk about how you name lines and segments. So we're going to start with some mental math to warm up. Let's do the tens first. So if you look at the 8, take away the 3, you know you've got 5. So 50 cents, now take away 5 more, and you've got 45 cents. Let's do that same trick here. You know we're still going to have a dollar because 1 minus 0 is 1. Now let's look at the tens. 6 minus 2. That would give us 40 cents, right? But let's take away another nickel, and you've got $1.35. Okay, let's do the dollars. 4 minus 1, that's 3, right? Now it's 5 minus 1, that would give us 4, so 40 minus 5, $3.35. Time. What month is 14 months after March? Well, you know that 12 months ahead, that's a whole year. It would be March again, right? So we just need 2 more months to make it 14 months. And what would that be? May. Cynthia finished her homework in 1 hour, 13 minutes. If she started at 4:05 p.m., what time did she finish? And we can add the hours together, and we don't have to worry about changing p.m. to a.m. unless we pass midnight, and we will not because 4 plus 1 is 5. Now let's add the minutes, 5 and 13, and all together, 5:18 p.m. How many milliliters is 2 liters? Now remember, I told you a milliliter was if you used a dropper, and the amount of liquid that would come out in that one drop would fill a centimeter cube. So that's about a milliliter. So how many of those little drops would fit into 2 liters, like a 2-liter bottle of soda pop? Well, Milla, I want you to think 1,000. There are 1,000 little drops in 1 liter. So in 2 liters, there would be 2,000 milliliters. And look how that's written. Little m, capital L. Estimation. Denise had $10.97. She spent $5.92. Round each amount to the nearest dollar and then subtract to estimate the amount Denise has left over. So let's round this one off. And $10.97 is really close to $11. $5.92 is really close to $6. So let's do 11 minus 6, and you've got $5. Okay, the trick for this one is to pretend in the beginning that this one is 30. So let's go ahead and do 43 plus 30 more would be 73. Now take away 1, 72. Now add that 72 on here. Still got 300s, but the 7 and the 1 would be 8. Still have 2. 382. All right, problem solving. This is the sequence of numbers we say when we count by fourths. Copy this sequence on your paper and continue the sequence to the whole number 5. And so they started with 1/4. And I'm going to make this look like a number line. And we're going to pretend it goes on forever in the opposite way too. So technically I should draw a little arrow right there. And we are going to start, this is our starting point, and it's said to count by fourths. So if we do 1/4, and then it said, let's double check, it said 1/2. It didn't say 2/4, did it? Okay, because 1/2 is the best way to say 2/4. So this would be 1/4, 2/4, 3/4, and then what? 1 whole. Okay, now I've got 1 1/4, 1 1/2, 1 3/4. I'm going to start putting my whole numbers down here, just so that you can see what that looks like a little bit better without being squished. Now we have 2 1/4, 2 1/2, 2 3/4, and then what? 3. Do you notice that if we had kept counting here, 1/4, 2/4, 3/4, this would have been 4/4, right? 4 sections, and we're talking about all 4 of them. So that's the same as 4/4. Okay? Now by the time, if we kept counting like this, 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4, 8/4. Okay? 9/4, 10/4, 11/4, 12/4. So that's another way to think about it. Okay, these are the best ways to write these though. So let's continue. 3 1/4, 3 1/2, 3 3/4, 4, 4 1/4, 4 1/2, 4 3/4, 5. Okay, so there's our number line, and we went all the way from 1/4 to 5. Okay, now we're going to talk about parentheses. And I had a friend that told me that her daughter learned it this way, that her teacher said that these parentheses were bunny ears. And so if you can imagine me hopping around the room saying, "Do me first. Do me first." That's what these bunny ears or parentheses means. You have to do what's inside of them first. It affects the outcome of the problem if it's subtraction, as you will see in just a minute. So 12 minus 4, that's what? 8. And the way I would like for you to handle this problem is like this. If you do this part first, I want you to write the answer underneath it and then bring everything else down, okay? And then 8 minus 3 is 5. Final answer on the bottom. Again, this is getting us ready for algebra. This is the way we're going to do it. Now I want you to notice that if we had done them out of order, if we had said 4 minus 3, that'd be 1, right? And then 12 minus 1 would be 11, so we would not have the same outcome. That's why it's very important to do those first. Okay, now this is addition, and that makes a difference, okay? And on this side, we have the 4 and the 5 associated together, and on this side, the same three numbers, but we have the 3 and the 4 associated together. So what's in parentheses? You have to do it first. 4 plus 5, that's what? 9, right? Plus 3, that would be 12. So keep that in mind. This side is 12. Okay, now let's come to this side, and we have to do this part first. 3 plus 4, that's 7, right? Plus 5, that would be 12. So what comparison symbol goes in the middle? It's an equal sign. And this is called the associative property of addition. And I want you to think, both of these problems had the same numbers, but two were associated in one side and a different set were associated on the other side. But did it affect the answer? No, it did not. Now that doesn't work for subtraction, okay, or division, but it does work, you will see, for addition and multiplication. So now let's take a look at a multiplication problem that shows the associative property. You see they have the same numbers that are involved, but on this side we've got the 2 and the 5 associated together, and on the right hand side we have the 3 and the 2. In addition, it did not affect the outcome. So let's see if it affects the outcome with multiplication. 2 times 5 is what? 10. Times 3 would be 30. Okay, let's check this side. 3 times 2 is 6. And 6 times 5 is 30. So guess what? Which two were associated did not affect the outcome. As long as you are working with the same three numbers each time, it doesn't matter which two you associate together first. So this is called the associative property of multiplication. All right, which segments in this triangle are perpendicular? Now remember, I think, okay, parallel, that's spelled with 2 L's right in the middle, and that is an example of parallel. And then I think perpendicular is exactly the opposite. It's where they come together and form a right angle. And it could look like a T, but as long as it is coming together and makes at least one right angle, then you've got perpendicular lines. So this is how you would write that. These are line segments, okay? And here's what I mean by that. Let me take a picture of this and put it on our next slide so that I can write on it. I want you to imagine that if this were a line, this would extend in both directions forever and ever, right? And this one would extend both directions forever and ever, and even this one could extend both ways forever and ever. But we're just talking about these parts of the lines. And when we talk about a part of a line, we're talking about a line segment. Okay, think of a little earthworm that is divided into segments. That's what his little parts are called, because they're a lot like a line segment. The two that are perpendicular, that make that right angle, are here and here. So we have to name them, and there's a proper way to name them. This one is called line segment PR. You could say RP, doesn't matter, but this is how you write it, PR, and you put a little segment above it. It does not have arrows on the end. So I would read this line segment PR. Okay, now if I'd put little arrows on the end, that means I'm talking about the entire line, but I'm not. I'm just talking about a little part of it. So this is one line segment. You have to have two to be perpendicular, and this is the other one. So what would I call it? I would call it line segment RQ, with that line right over that. So one of the things I would expect you to do is to be able to look at this and read it properly. So which segments in this triangle are perpendicular? Your answer would be line segment PR and line segment RQ. Right, moving right along. Okay, name another pair of segments that appears to be parallel to AB. So let me take a picture of this one. And we are looking for a line segment that is parallel to AB. So this one right here. That's as close as I can get to tracing a straight line with this pen. Okay. And remember, parallel means they're like train tracks right together. And I see that this one could, and also that this one could. But let's do this one first. So name a pair of segments that appear to be parallel to AB. We could say line segment DC and look at this. This is even harder to visualize. And let me do those in a different color. And another pair that we could put together, EF and HG. So line segments AB and DC are parallel, and also line segments EF and HG are parallel. Okay? Now we could have done that opposite. We could have said AB, line segment AB is parallel to line segment EF, couldn't we? And we could have also said line segment DC is parallel to line segment HG, and we still would have been correct. All right, now it's asking a different question here. Name two segments that appear to be perpendicular to AB. Okay, and remember, perpendicular means they are going to be forming right angles. So look, right here, right here, right here, or right here. So we've got like four possibilities that all go into line segment AB and make those 90-degree angles. Okay, example 6. The length of, now this is how you say it, okay? The length of line segment AB is 3 centimeters. The length of line segment BC is 4 centimeters. I'm sorry, yes. What is the length of line segment AC? So if we know if this side is 3 and this is 4, then the length of line segment AC is 7 centimeters, correct? Okay. Let's look at our lesson practice. And remember, parentheses means bunny ears hopping around. Do me first. Do me first. And a lot of these are so simple we can do them mentally. So let's go for it. 4 plus 2 is 6, right? Okay, 8 minus 6, you got it, 2. 8 minus 4 is 4, plus 2, 6. Remember, do me first. 6 minus 3 is 3, and 9 minus 3 is 9 minus 6 is 3, and 3 minus 3, 0. 2 times 3 is 6, plus 10 is 16. See, they're mixing up the signs on us now. You've got to watch. 10 plus 20 is 30 times 3 is 90. And we have to compare. And this looks like associative property of addition, and this one looks like associative property of multiplication. Okay, 3 plus 4 is 7, right? Plus 2 is 9. Keep that in mind. Now 2 plus 3 is 5. Plus 4 is also 9, so they're equal. And they should have been. Okay, let's double check. This should be equal too, right? 4 times 5 is 20, and 20 times 3 is 60. 3 times 4 is 12, and 12 times 5 is also 60, so it's equal. What property of addition and multiplication is shown by the comparison in G and H? Well, we just said it, the associative property. Okay, the length of, now this one's trickier, the length of line segment RS is 4 centimeters. The length of line segment R all the way to T is 10 centimeters. What is the length of S, line segment ST? So I like to think of it this way. I like to think I know what R to S is, that's 4. But I've got a question mark here. I don't know S to T, so I can say 4 plus X equals a total of 10. So let's try that. 4 plus X equals 10. And remember, if we do a fact family, we'll figure it out. There's my 2 addition problems, but still, I cannot solve either one of these because I don't know what X is. So let's do our subtraction problems. 10 minus X equals 4, and also 10 minus 4 equals X. So here it is. This is the one that we can solve. And 10 minus 4 is 6. So 6 equals X. Which segment in this figure appears to be the diameter of the circle? And you know the diameter is all the way across and it has to pass through the center. So that would be line segment LJ, or you could also say line segment JL. Which segments are perpendicular? Well, that would be line segment LJ and line segment MK. Does anybody remember what this is called? If this is the diameter that goes all the way across, then halfway across, or from the center point to one side of the circle, is the radius. Just thought I would throw that in there. Refer to the figure in example 5 and name 2 segments that are parallel to a line segment BC. So I have saved that. I remember which one it was. I've got a clean copy of it, though, for us to work with. We've got to figure out which ones are parallel to line segment BC. Do you see that? Okay. Do you see that this one looks like train tracks? So line segment FG. So we could say line segment FG. What else? Line segment AD. And I wonder if they include EH. I bet you could. And line segment EH. Because you could imagine I imagine a big square piece of plywood that's flat, and that's what I imagine a plane to be, P-L-A-N-E. And a plane could pass through these two, so they could be parallel. Let's see if they named all 3 of those. They sure did. Okay, you are ready now to go back and check 44 practice. So hit pause as you check 1 through 8. Hit pause as you check 9 through 22. Hit pause as you check 23 through 30, and then you will be finished.